In this video, we'll discuss mole conversions. Remember that when you have to convert between particles and moles, you use Avogadro's number. When you convert between moles and mass, you use molar mass. When you convert between moles and the volume of a gas, you use 22.4 liters. So the first thing you do is you read the question. And in this question, it's asking for the number of grams and 3.70 moles of iron 3 hydroxide. This is a mole to mass problem, so we would use molar mass. And you have to actually calculate this molar mass. So we get the mass of 1 iron, 3 oxygens, and 3 hydrogens, and that'll give you 106.866 grams. Since we start with moles, we have moles on top, we need moles on bottom, and you can tell from this tile that this is incorrect. We have our molar mass, we have our moles, but it's the wrong orientation. So you flip the tile, and now we have moles on top, moles on bottom, it cancels. Now notice that our conversion factor, we have a number other than 1 on top. So we multiply. 3.70 times 106.866 grams. You multiply these two, that gives you 395 grams of iron 3 hydroxide. You also have mole conversions where it requires more than one conversion factor. In this problem, we're converting from 143 grams of aluminum to atoms of aluminum. We start off with grams, so we need molar mass for our first conversion factor. In this case, what we're doing is converting from grams to moles. We put grams on bottom, so it'll cancel. But we're not looking for moles, we're looking for atoms, so we're not finished yet. So we need a conversion that'll take us from moles, because that's what we have here, moles, to atoms. An atom is a type of particle, so we use Avogadro's number. That goes in the next conversion. So this is a two-step. We have two conversion factors. Since we have moles on top, we need moles on bottom. So you flip the tile, moles cancels, top and bottom cancel. And then to calculate this, it's 143 divided by 26.983 times Avogadro's number. And that will give you 3.19 times 10 to the 24 atoms of aluminum. And then there are other types that require more conversion factors. So for example, this problem, we're converting 275 grams of iron 3 hydroxide to atoms. And the last one, we went from grams to atoms, but it wasn't a compound, it was an element. It was just one. It was one type of matter, it was an element. Well, now we have a compound, so we need to get the total number of atoms. Well, you go from grams to moles, you can go from moles to particles, and then we have to figure out how many atoms are in that particle. So the compound is the particle, right? Iron 3 hydroxide is the particle. In iron 3 hydroxide, we have iron and we have hydroxide. Well, if you write the formula is FeOH3. So that's 1 iron, 3 oxygens, and 3 hydrogens. So we have to go step by step. And our first conversion factor, we have grams. So we need to get the molar mass of iron 3 hydroxide. Well, we have a lot of options here, right? Well, this is our molar mass. So we take our molar mass in the first conversion, we have grams on top, grams on bottom. So now we have moles. We've just converted from grams to moles. So we need to convert from grams to particles. We're trying to find how many in 106.866, how many iron 3 hydroxide compounds there are, or really its formula unit is what you would say. So we need Avogadro's number. Then there it is. There's Avogadro's number. So moles on top, moles on bottom. We don't have moles on bottom, so we'll flip the tile. Moles on top, moles on bottom, cancels, and that gives you Avogadro's number on top. That's formula units. So at this point, what we've done is we have determined that in 275 grams, there are 1.55 times 10 to the 24 formula units of iron 3 hydroxide, but we want atoms. So how many atoms do we have? For every formula unit, you have 1 iron, 3 oxygen, and 3 hydrogen, so that's 7 atoms. So for every 1 formula unit of iron 3 hydroxide, there's 7 atoms. Since we have formula units on top, we need formula units on bottom, so we flip the tile. Look at this, we have 1, 2, 3 steps, 3 conversion factors in this problem. Grams cancels, moles cancel, formula units cancel, and that leaves us with atoms, which is what we're looking for. We're trying to find atoms. So 275 divided by 106.866 times Avogadro's number times 7.